Quadratic equations. Now, this is our topic of study today, and as you join to this class, like and subscribe to this channel. Okay, by definition, a quadratic is any expression of the form ax squared plus bx plus c, and a should not be equal to 0, because if a is 0, it will affect the format of quadratic expression, of quadratic equation, and it will no longer be a quadratic equation anymore. So we can get a quadratic equation by expanding the following factors. So we have x plus 1, then x plus 3. If you expand this, you'll get x squared plus 4x plus 3, and this exists in the format of a quadratic expression, that is ax squared plus bx plus c. Now, you have already multiplied out pairs of brackets and factorized quadratic expression, and that is why we have our equation as above. Now, quadratic equations can be solved by factorizing or by using a graph of the function. Now, we are going to look at how to find the roots of quadratic equations by factorization. And consider the example below: x minus a, x minus b equal to 0. And you're asking yourself how you can solve this. Now, we know that if we have c times d, you get 0. And then that means what? That means that c is equal to 0, or d is equal to 0, or even c is equal to d equal to 0. Now, that is what is happening here. Let's go back to our example. We want to expand this, and it is equated to 0. So later on, we will be finding out the roots to this expression. Now, this is the same as x minus a, x minus b equal to 0. Then this means that the first part, we equate the first factor to 0. So that is x minus a equal to 0. Or it can also be that x minus b equal to 0. So of course the first part will give us x is equal to a, and the second part is x is equal to b. I think that is clear enough. Now let's try to work out with a real example. Solve 3t minus t squared equal to 0. So as you can see, this is a quadratic equation. And now we are going to factor out. Of course, we have t appearing in both terms, so we can factor out t. So it will be t into 3 minus t equal to 0. So this means that t is equal to 0, and 3 minus t also equal to 0, because we have formed two parts of the expression. Now, the first part is t is equal to 0, and the other one is 3 minus t equal to 0. And this will give us t is equal to 0 or t equal to 3. So the t being equal to 0 and t equal to 3, these are the roots of the quadratic equation above. Now, number 2, solve 2x plus 6, 2x minus 3 equal to 0. So we are going to solve the first part, of course equate it to 0, the second part as well, and then you'll be able to find the roots. The roots, of course, these are the values of x. So x plus 6 is equal to 0, and on the other part, 2x minus 3 equal to 0. And now the first part gives us x is equal to minus 6, and the other one we have, of course, we take 3 the other side, because when a negative number crosses equal sign, it changes to a positive number. Now we have 2x minus 3, so our value there is 3 over 2. Now the roots are x equal to 6, x equal to negative 6, or x equal to 3 over 2. Let's now make a summary on factorizing quadratic equation. So what really do we have when we are factorizing quadratic equation? Number one, we have a common factor, like for example in this case, 6x squared minus 18. This one, of course, there is a common factor, and 6 can divide into the two terms. Now we have 6 into x squared minus 3. Number two, you can also find a difference of two squares when you are working with quadratic equations. Like in this case, 4x squared minus 9. This is a difference of two squares, and so we have it that 2x plus 3 and 2x minus 3. The difference is in the signs. Number 3 that you should also check is now factorize. Factorize, when you are given a quadratic expression as x squared minus x minus 2, then you can factorize this by getting x minus 2, x plus 1. I believe you know how to factorize this concept, because if you have been with us in this lesson, then probably you know what is happening here. Now, let's now look at the solution of quadratic equation. So before solving a quadratic equation, make sure it is in its standard form. We are talking about the format in which a quadratic equation is written. And so, this is ax squared plus bx plus c equal to 0. It must be equated to 0 for it to form an equation. Otherwise, it will be a quadratic expression. So, few examples. Number 1, solve 4x plus 1 equal to 5x. So, as you can see, this on the left hand side, it is not really a quadratic equation, but we can make this a quadratic equation because we are looking at the format. We want to write it in the format ax squared plus bx plus c equal to 0. So we are going to take 5x from the right hand side to the left hand side, so that we will be left with 0 on the right hand side. So this means that 4x squared minus 5x plus 5 plus 1 equal to 0. And so by factorization on the left hand side, we'll have 4x minus 1, then x minus 1 equal to 0. So working on the first part, we'll have 4x minus 1 equal to 0, and this will give us 4x equal to 1, and the value of x now is 1 over 4. That is the first root. On the other part, x minus 1 equal to 0, and the value of x is 1, the second root. And now the solution for this is x equal to 1 over 4 or x equal to 1. Solution of quadratic equations using quadratic formula. Quadratic formula. Now, what happens if you cannot factorize the quadratic equation? If you cannot factorize the quadratic equation to get the roots, that is the value of x or the value of any given unknown in the quadratic equation, then probably we have a solution for you. You definitely go for a quadratic formula. So ax square plus bx plus c equal to 0. That is the format in which a quadratic equation is written. And now from that, we can use completing the square method to get this formula, which we call the quadratic formula. So the formula have it that minus b plus minus square root of b squared minus 4ac over 2a. Now we want to work out some few examples using the quadratic formula so that we see the fact of it. Number 1, solve the equation 2x squared minus 5x minus 1 equal to 0. In this case, you are required to find the value of x by using the quadratic formula. Yes, you can solve it using other methods like completing the square method, like factorization, but if the question requires you to work it out using quadratic formula, then you should follow that condition. And now we need to compare this with the format in which a quadratic equation is written, that is ax squared plus bx plus c equal to 0. And so we have that a is equal to 2, b equal to negative 5, and c equal to negative 1. Now substituting it into the formula, x equal to minus b plus minus square root of b squared minus 4ac over 2a, you have it that minus b and b itself is negative 5. So minus will give you 5. So you watch on your negatives. You watch on the negatives so that you don't really get a wrong answer. So 5 plus minus, because we have minus b, should be inside the bracket. If you b squared in this case will be minus 5 into bracket square. Otherwise, if you say it is minus 5 square without putting that minus 5 into bracket, then you will not get the correct answer. You will get negative 25. But minus 5 into bracket square minus 4 times 2 times minus 1 over 2, and our a is 2. So that one you will simplify it and get 5 plus minus root of 25 plus 8 over 4. So the first part, of course, we have minus plus, and that means you are going to get it in the first part and the second part. So the first part is when you take the positive 5 plus root of 33 over 4, and the other part is 5 minus root of 33 over 4. And now our roots are 2.69 and negative 0.19, correct to 2 decimal places. These are the values of x, possible values of x. Now, quadratic equations as mathematical models. We are going to look at now a situation in which quadratic equation can be used or it is applied. So the question here, the length of a rectangular tile is 3 meters more than its breadth. Its area is 18 meters squares. 18 meters square. Find the length and breadth of the carpet. You have to represent this in a diagram so that you comprehend whatever is in the question clearly. So the breadth, we were told this statement should be underlined so that, because it is what is going to help us do the question. If you misinterpret, rather misunderstand this statement, 3 meters more than its breadth, that is where you should concentrate on. Okay, so that means that the width of this a rectangle is going to be x, and the length will be x plus 3, because you are told more than. Now that we've been given the area of the rectangle, and we know it is length times base, length times width, sorry, then we can substitute into the formula. So we have 18 equal to x into x plus 3. Then we solve it out. If you simplify that out, you'll get a quadratic equation. That is x squared plus 3x equal to 18. And now from there we can form a quadratic expression, a quadratic equation, sorry. That is x squared plus 3x minus 18 equal to 0. And from there now we can solve it using any method. We can use factorization, we can use quadratic formula, we can also use completing the square method to solve this out. And now x plus the factors are x plus 6, x minus 3 equal to 0. And so the first part, of course, will have x plus 6 equal to 0. Then the second part, x minus 3 equal to 0. So first part, having that x is equal to negative 6, and you know very well that the length of this rectangle, length cannot be stated in negative, and so we rule out negative. So it is not a possible solution for the length. So we consider x minus 3 equal to 0, which will give us x is equal to 3. So this have it that the width of this carpet is 3 meters, and the length is 6 meters, because the value of x is 3, and the length, the expression for the length was x plus 3. So 3 plus 3 gives us 6, and that is the length of the diagram or the rectangle. Let's now move to graphical solution of quadratic equations, and we are going to work out the first example. Use the graph below to find where x squared plus 2x minus 3 equal to 0. Now the function has been given, so what we want to get here is the values of x, because the values of x is at the point where the graph and the x-axis are meeting, and that is the solution for the quadratic equation graphically. So if it is graphically, then of course you are provided, in this case you are provided with the graph, but normally you are being given a function, then you'll be able to come up with a graphical solution, a graphical work to find the roots or to find the solution for the quadratic equation. Now, x squared plus 2x minus 3 equal to 0. That is when the graph crosses the x-axis, and definitely that is what we are using here. So, we have it that x squared plus 2x minus 3 equal to 0 when x is equal to minus 3 and x is equal to 1. Because this graph, the curve is cutting on the x-axis, that is y is equal to 0. The line y is equal to 0 at x is equal to negative 3. And on the right hand side, x is equal to 1. And now these are the roots, or these are the points where x squared plus 2x minus 3 is equal to 0. So we move to sketching quadratic functions. To sketch a quadratic function, we need to identify where possible. There are factors that we need to put into consideration to be able to sketch a quadratic function. Now, the shape ax squared plus bc plus c should be plus bx. Ax squared plus bx plus c. And now we have it that if a is greater than 0, then we will have a u curve. A u curve. And if a is less than 0, then probably less than 0 means it is the value of a being negative something, negative coefficient. Then probably the shape will be an inverted u. An inverted u. And now the y-intercept also should be factored out to be able to sketch a quadratic function. So the y-intercept, of course, we know very well that at y-intercept the value of x is equal to 0. And if you were to write the coordinates of the y-intercept, then probably the value of it will be 0 something, 0a, 0c, 0b, you see. So that is what we are talking about in this case. Now the roots, by solving ax squared plus bx plus c equal to 0. The axis of symmetry, that is the midway between the roots. And then also another thing to consider is the coordinate of the turning points. The coordinate of the turning point. Now we want to look out a real example to be able to sketch the graph of the function of y in this case. So y is equal to 5 minus 4x minus x squared. And now the coefficient of x squared is negative 1. So the shape is going to be an inverted U shape because of what we just said, that when a is less than 0, then the shape is going to be this one displayed here. So we want to work out very fast on the y-intercept. Y-intercept will be 0, 5, because y-intercept is the value of a y when x is 0. So you substitute in the equation of y the value of x, which is 0. So we shall have y is equal to 5 minus 4 into 0 minus 0 square. So that will leave you with 5. So the coordinate of the y-intercept is 0, 5. The other thing is the roots. And now we have our equation 5 minus 4x minus x squared is equal to 0. Now this one can be solved using any other method that we have learned. We have that we can use factorization, we can use quadratic formula, we can use completing the square method. And by factorization, we have it that 5 plus x minus 1, equal to 0. And the first part, if equated to 0, you get negative 5. The second part, equated to 0, you get 1. Now, those are the values of x. We have that x is equal to 5, x is equal to negative 5, and x is equal to 1. And now from here, we are going to substitute for the value of y so that we come up with the coordinate. Because now you want to plot, you want to sketch a graph. So it will be negative 5, and the y, when you substitute negative 5 in the equation, y is equal to 5 minus 4x minus x squared, you will get the value of y to be 0. And so that will give us the coordinate, the first coordinate as negative 5, 0. The second one will be 1, 0. Okay, the axis of symmetry, the midway point, the midway between negative 5 and 1 is negative 2. And probably that is what we get. Now, when x is negative 2, what is the value of y? So the coordinate of the turning point, that's why we are where we are asking when x is negative 2, the value of y probably will be 9. So with that, we get the coordinate of the turning point as negative 2, 9, negative 2, 9. And now with all that information, we get to sketch our curve, our graph, and we have it as displayed here. Now, straight lines and parabolas. So in this chapter, we will find the points where a straight line intersects a parabola. Number 1, find the coordinates of the points where the line y is equal to x plus 1 cuts the parabola with the equation y equal to x squared minus 5x plus 6. So we have the graph here. So we have the points of intersection, where the line and the curve are meeting. And now the solution for this equation, which is a quadratic equation, will be the values of x on the x-axis, where the curve and the straight line, the linear line, a linear equation are meeting. So at the point of intersection A and B, the equations are equal. And therefore we say that x squared minus 5x plus 6 equal to x plus 1. We equate the two equations so that because the two lines, a line and a curve, are intersecting at points A and B. So to be able to get the values, the point on the x-axis where they are intersecting, then we need to equate the two equations. So that one will give us x squared minus 6x plus 5 equal to 0. By factorization, you get x minus 1, x minus 5 equal to 0. And this one will give us x equal to 1 and x equal to 5. So you can definitely see that point A is when the value of x on the x-axis is 1, B, the value of x on the x-axis is 5. And now you can substitute these two in one of the equation. So in this you get the coordinate at point A is 1, 2, and at point B is 5, 6. And that is the end of our lesson.